The Constitution of India, Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Happy morning to all my dear children. I know you all are busy right now, getting up early, doing some physical exercise, making yourself more energetic, and of course you have started learning more, planning yourself to achieve good marks in your board exam. Because laziness is a very big problem and it's a very bad attitude a child must possess. Do you agree with me, children? Because once we are lazy, we don't feel like doing things at proper time. We always think, let me do it tomorrow. We always postpone our things. We don't keep a track of what we need to do. So, I want all my children to be active, avoid laziness, start doing your things regularly on time, keep yourself a timetable so as to achieve good marks in your +1 board exam. I am getting into a topic called thermodynamics, where we are going to study about the exchange of energy transformation, because we know energy can neither be created nor be destroyed, or we have studied matter can neither be created nor be destroyed. Law of conservation of mass or law of conservation of energy. Now here thermodynamics is a study where we are going to learn about the energy transformations in a system which is macroscopic. When I say macroscopic, it consists of a large number of molecules. So we are not going to study at the microscopic level. Instead, we are going to focus on a macroscopic level of exchange of energy between the system and the surroundings. Here, we are not going to study about the rate at which the energy change takes place. Instead, we are going to focus on the initial and the final state of the system. What happens at the initial state, how the substance is present, and at the final state, how the product is formed. So these are the things we are going to focus in thermodynamics. Because there can be many questions within us. Why this reaction happens, or to what extent the reaction can continue? What are the changes or factors that are responsible for this reaction to occur? So for these questions, we are going to study about thermodynamics. When I say thermodynamics, it primarily includes two important terms, which is system and surroundings. System. System is a part of the universe where the observations are happening or my experiment is being done. So when I take a beaker, I pour water into it, I pour salt into it. So there is a reaction that is happening between my water and salt. That particular beaker is called as a system, inside which the reaction is proceeding is called as a system. Now the remaining part of the system is called as my universe. Whichever is being supporting for the system to happen is called my surrounding. So the system and the surrounding will make up a universe. Now there is a wall, a boundary that separates the system from the surrounding. That we call it as a boundary, a wall which separates system and surrounding. Now these are physical boundaries. It can be my beaker, it can be my vessel, it can be my test tube, it can be a conical flask. Any particular physical boundary which can be real or it can be an imaginary surface into which the system is proceeding with an observation. Surrounding is my remaining part where it supports, it interacts with the system. This surrounding always interacts with the system. It depends on the temperature factor, how the system observations are made. So together it will make a universe. So here we are going to study about some types of system which are included for this year. The first one is an open system. Open system, something that is kept open. The reaction is going to happen in an open vessel, in an open beaker, where there is an exchange of energy and matter. What is matter? The substance itself changes into another substance. Exchange of energy from hot surface, it can be cold to a cold surface. There is a change of energy and a change of matter. Such system and surrounding together, we call it as an open system. So here you can take a reaction happening in an open beaker, water boiling in a vessel which is kept open. So all these are the examples where the reaction is happening. There is an exchange of energy and matter between the system and the surrounding. Such a system we call it as an open system. Now we will learn about the other two systems also. So now we will learn about what is a closed system, because in open system we came to know that there is an exchange of energy and matter between the system and the surroundings. In a closed system there is no exchange of matter, that is the reactants are kept as such and they are not changed, but there is an exchange of energy. Now you take an example where we have a closed vessel which is made up of a conducting material like copper, steel. So what happens is that the reactants which are kept inside, there is no change in that, but the system, the boundary here is made up of copper, so it can absorb the external heat or it can make the vessel cool or it can make the vessel hot. So there is an exchange of energy, but there is no exchange of matter. Such a system which is made up of a conducting material where reactants are kept is called as a closed vessel or closed system. Now what is an isolated? You know what is isolated? Now you know here, now when we test with COVID-19 or we are kept in an isolated room where there is nobody to interact with us. There is no exchange of anything that is happening between that person and the other person. Isolation means kept separately. It's called as isolation. There is no exchange of energy or matter between the system and the surrounding. Now in closed system we said it is kept in a conducting material. Here the reactants are kept in a closed vessel which is a thermoflask or an insulating material. So when we keep in an insulating material, there is no exchange of energy or there is no exchange of matter. So these are the important three systems. Next we have state of a system. What do you mean by state? Because I told you in thermodynamics we are learning about the initial and the final state of a system. So it is definitely important that we focus on some properties like pressure, volume, temperature and composition, which is nothing but the amount of the substance. In physics you would have learned that at one particular time the distance covered is so much, so you calculate the speed or velocity. So for every single thing that we calculated, there are some definite properties, definite variables which are important for us to understand how the reaction is happening or how does it reach from initial state to final state. So to understand that, we have certain functions or certain variables which depend only on the state of the system and it does not depend on how it is reached or how that reaction has reached this place. So that particular properties we call them as state functions or state variables: pressure, volume, temperature and N, which is the amount of the substance. These four are called as the state variables or state functions, as they play a very important role in determining the change of energy or matter that is happening between the system and surrounding with its initial and the final state. So, such systems is called as a state of a system. Now, we have something important, which is internal energy, where we will be focusing on the work, heat and other factors that are governing the system. So, here we were seeing about the state of the system, and now we are going to learn a new term which is called as an internal energy. Now, whenever there is a process that is happening, any process that is happening, there is some loss of energy or some gain of energy. Energy is being gained or energy is being lost. But there is some total sum of energy, some of this total energy which is being lost and gained in the system. We call that as an internal energy, which is sum of all the energies of the system, right? Now, that can change. When does an internal energy change? When the heat passes into the system or when the heat comes out of the system. So, you can provide heat into the system or you can take out the heat from the system. When work is done on the system or when work is done by the system. Similarly, when matter enters the system or matter leaves the system. So, these are the different ways in which there can be a change in the internal energy. So, let us learn about this internal energy through few applications. One is work, then we have heat. Now, for work, let us take a thermoflask, the system where it is an isolated system where there is no exchange of energy or matter. So, when water is taken in an insulated vessel or a thermos flask, there is no exchange of heat. That particular word we call it as adiabatic. Adiabatic is a process where in that process there is no transfer of heat between the system and the surroundings. It is absolutely nil. The wall that separates the system and the surrounding for not allowing them to exchange their heat, we call them as adiabatic wall. So, this is a initial state, right? There is nothing happening. Now, let us bring a change of internal energy into this. Now, how can we do it? We are going to work on the system. We are going to work on the system. There are two methods by which we can do this work. One is by rotating the paddles to churn the water. That is, the water is going to get disturbed by rotating the paddle. So, what is happening? The initial state will be A, where the temperature of that particular state will be TA, having an internal energy of UA. After the work is being done on the system, it reaches a final state B. TB will be the final temperature and UB will be the final internal energy. And as we know, since the work is done on the system, the temperature TB of the final state will be greater than the initial state. So, definitely UB will also be greater than UA. So, change in temperature will be TB minus TA and change in internal energy will be UB minus UA. This is the first method where we do a manual change on the system. Now, let us see the second method where we are going to apply some electricity by doing a small work on the system. So, in the first method we saw the the work is done on the system by creating a 1 kilojoule of work by rotating the paddles, that is mechanically. But here we are going to do an electrical method where there is an immersion rod kept to disturb the water. So, again work is done on the system, initial temperature TA, final temperature TB. So, change in temperature will be TB minus TA. Now that work which is done on this adiabatic wall, we call it as a adiabatic work, that is W adiabatic. So the change in internal energy will be U2 minus U1, the final change minus initial change, which will be equal to work done in an adiabatic process. Now this work done will be positive if the work is done on the system. When you do the work on the system, some of the internal energy is being gained on the system, so the internal energy increases. But when the work done is negative, which means work is done by the system. See, simple, when I get chocolates, I am so happy. I am not spending any money, I am getting it free of cost. But when I have to give you chocolates, I need to spend money, I should buy something for that and then I should give you. So that is lost by me, which will be negative. So when work is done on the system, it is a positive work done, internal energy increases. When work is done by the system, it is negative, where internal energy decreases. This is the application of work. But now we are going to learn where heat also plays an important role in internal energy. Here, when we were studying about work done on the system, we took an thermos flask, that is insulated material. Here we are going to take a conducting wall which is not allowing the matter to exchange, but there is a change of heat. There is a transfer of heat between the system and the surrounding. So we take a conducting vessel which is made up of copper. We have water inside. The change in energy will be the temperature difference, which is Tb minus Ta, which is defined as Q, which is a heat. Now the transfer of heat between the conducting walls is shown here. Ta is the temperature of the system within inside. Tb is the surrounding temperature where it is kept in a big heat reservoir. So the change in internal energy will be Tb minus Ta, which is nothing but the Q, change in temperature difference. Since there is no work done, W is 0. So del U is equal to Q. Now when the heat will be positive? The heat will be positive if the heat is transferred from the surrounding to the system. When the system gains heat, it becomes positive. So there is an increase in the internal energy. When the heat is given out to the surrounding, from the system to the surrounding, my Q will be negative, where there is a decrease in the internal energy. So these are the most important things which you should learn with heat and work. Now overall, in general case, what happens to work done and the internal energy and the heat, we will see now. So we were seeing two applications where we saw when work is done on the system or when the heat is transferred from the surrounding to the system. Now this is a general case where we are going to study if there is a change in the internal energy brought by two important factors where work is also done, heat is also transferred. So if there is two cases where both work and heat is being participating, then del U, change in internal energy, will be equal to Q plus W, sum of heat plus work done. Now this internal energy or the heat or the work, they totally depend on the initial and the final state of the system. W will be equal to 0. When there is a situation where work done is 0, if there is no work done on the system or by the system, then W becomes 0. When Q becomes 0, when there is no heat transferred from the system to the surrounding or from the surrounding to the system. At both these situations, W becomes 0, Q becomes 0. So del U becomes 0 because this del U is the sum of Q plus W. So these becomes 0. So what is del U here? Q plus W, which is called as a first law of thermodynamics. So first law of thermodynamics is a very important law which states that energy of an isolated system is constant. It does not change. Energy of an isolated system is constant, which can also be restated as the law of conservation of energy, which can neither be created nor be destroyed, because we know it transforms from one form to another form. So, with this the internal energy is getting over. Now, we are going to learn internal energy into deep with the applications of work and heat. So, let us learn how this application is being useful. Now, we will learn about the applications of internal energy through work. Now, when we consider work, let us consider a mechanical work, which is nothing but a pressure volume work, a change in pressure and volume. Consider a cylinder which has got 1 mole of an ideal gas inside. Now, when we apply an external pressure from outside, when work is done on the system, this pushes the piston downwards through a distance of L. From the initial volume V, the volume decreases to a final volume Vf, because we know when there is more pressure, the volume becomes less according to Boyle's law. So, whenever there is an increase in the pressure, that is, we are going to apply an external pressure which is more than the pressure of the gas. So, what happens? The volume will decrease, it changes from Vi to Vf. So, Vi will be the initial volume, Vf will be the final volume, P is the pressure of the gas that is inside, Px is the pressure of the external gas. The distance moved by the piston will be L along the cross sectional area A. Now, what happens here? There is a change in the volume which is given by length into the area of cross section. So, that can be defined as del V, which is nothing but volume final minus volume initial. We also know pressure is equal to force by area, and force is equal to pressure into area, where here pressure becomes my external pressure which is applied by the piston on the system. So, P external into area. Here we introduce a new term, that is work, because we are changing the work done on the system. Work is equal to force into distance. Force is nothing but P external into A into distance is L, but we already know A into L is nothing but my del V. So, here I put P external into minus del V. Why I introduce this negative sign is because the difference between Vf minus Vi will be in negative, because volume initial was more. As the pressure external is applied, we know pressure increases, volume decreases. So, there is a small value minus the big value will be a negative sign. To make W a positive, to get the work done being positive number, we introduce a negative sign. So, negative into negative will become positive. Now, there are two situations where the pressure may not be constant, right? At each stage of compression, the pressure will be changing at a very small step. So, I can take a summation of minus P del V, or in another case, since the pressure becomes more with the change in the compression, the volume decreases. So, that decrease in volume will be dV, which can be written as minus integral of V initial to V final P external into dV. This will be the work done. Now, let us complete this by learning what is P external and how to introduce P internal pressure in the equation. So, children, we stopped with P external will be equal to sum of P internal plus or minus dP, which will be the change in the pressure. If the external pressure is greater than the internal pressure, this will be positive or this can be negative. This happens only in two conditions where the process can be reversible or it can be irreversible. Reversible process are those where you know the whole process can be reversed by there is a change in the pressure, or the whole process cannot be reversed, right. Now, we are going to focus on the internal pressure of the system, which is P internal under reversible conditions. So, let us take W reversible, where work done is going to be a reversible process, minus integral of V initial to V final P external dV. Now in the place of P external, I am going to substitute P internal plus or minus dP. So what happens here? When it is plus or minus dP and dV, this dP, change in pressure, can be very small. So I can write this equation as W reversible minus integration of Vi to Vf will be P internal dV. I am going to neglect this dP factor. So this dV, P internal dV, I am going to take P internal in terms of pressure of an ideal gas for n mole of a gas, because we know ideal gas equation PV is equal to nRT. So P will be nothing but nRT by V. In the place of P internal, substitute the value of nRT by V. So here I have dV, so I can take nRT dV by V. Bring this nRT outside the integration, so it will be nRT, remove this integration and write here natural logarithm ln. So ln of Vi in the denominator, Vf in the numerator, which is a ln of V volume final by volume initial. To remove this ln, we introduce minus 2.303 T, which is the most important, minus 2.303 nRT log of Vf by Vi. To convert ln into log, you will multiply with 2.303. So this is work done in the reversible conditions. Now in your textbook, please mark children, page 166, you have isothermal and free expansion of an ideal gas, where you have been given 1, 2, 3 important points. Mark it important, you need to by heart it. Okay. Now we will get back into enthalpy. We have been learning about the heat energy of the system, internal energy of the system. Now we are going to focus on enthalpy, which is again a change in the energy, that is heat energy. Let us now learn about the types of thermodynamic systems. In a thermodynamic systems, where we have the heat radiation or the evaporation, condensation, precipitation, there is a transformation of energy from one form to another form, and this is a continuous process. Such a process takes place with the transfer of energy or matter within or outside the system. A thermodynamic system or thermodynamics, we consider a system into which the observations are done, and the external factors which depend or which account for the change in the system are surroundings. System plus surroundings makes the universe. The boundary that separates the system and the surrounding is called as the boundary or the line. There is a salt solution inside the system where there is a complete mixture. We call it as a homogeneous system. A mixture of sand and water which does not make a uniform is called as heterogeneous system. In a salt solution, you can see there is an energy transformation from the system to the surrounding. This depends on three types: open system, closed system and isolated system. Let us learn each of the systems one by one. An open system. An open system is a system where you have a container with a content inside. There is an exchange of matter and energy from and within the system and surrounding. Aqueous salt solution inside the container is a system when a salt is added with little of water. Now you can see after stirring the system inside, the energy is produced when it is stirred. Energy is induced in the system by heating. So here there is an exchange of matter as well as energy which is taking place between the system and the surroundings. Energy in an open system does not remain constant. There is always a transformation of energy. Closed system. You take a same container which is closed with a lid where there is no exchange of matter but there is an exchange of energy taking place. A system of aqueous salt solution, when it is covered with a lid, that is, there is no transfer of matter to the surroundings, but there is a transformation taking place with energy when it is heated. So, when it is heated, you can see after some time the vapors, when they form or cover the lid, there is a fog or vapors condensing within the walls of the lid. So, the matter is not exchanged, but the container becomes hot. So, there is an exchange of energy because outside the temperature is cold. So, this system we call it as a closed system. Next, we will learn about isolated system. In an isolated system, we take a thermos flask where there is no exchange of matter or energy. Thermo flask is a flask which has a container on the top that does not allow the matter to get exchanged between the system and surroundings. And the flask is made in such a way that hot water remains hot and cold water remains cold, and there is no exchange of energy taking place between system and surroundings. As there is no transfer of matter or energy between the system and surroundings, there is called as an isolated system. So, this is a summary of the three types of system in a thermodynamics. Let us now learn the internal energy and first law of thermodynamics. Consider a system which has a solution inside such that it can transfer the energy to the surrounding in the form of heat energy, potential energy, kinetic energy, or any forms of energy. The sum of all the energies which is being transferred or the amount of energy possessed by a substance is called internal energy or intrinsic energy. This internal energy depends on some of the factors which are composition, volume, temperature, and pressure. So, when there is a variation in any of these factors, the internal energy of the system will be disturbed. Let us now learn about the state variables, the factors which are responsible for the internal energy. Through two things, one is work, the other one is heat. So, these two applications will help us. The internal energy of a substance may change when work is done on or by the system, heat is transferred into or out of the system, matter enters or leaves the system. Consider an example of a beaker containing a solution inside. Work is done by applying pressure. So, let us now learn about the change in internal energy by two applications. One is work, the other one is heat. So, what happens when the work is done on the system by the internal energy? So, consider a closed vessel in which a solution is kept inside, where we have a temperature inside that is maintained, that is because of an insulated beaker. So, the heat energy or the matter do not enter or leave the system. In such a case, let us assume what happens at the initial state. At the initial state between the system and surroundings, A is the initial state of the system, TA is the initial temperature of the system, UA being the internal energy of the system. So, when there is a change in internal energy, by doing a mechanical work, by rotating the solution, the temperature changes from TA to TB, and there is a final state of the system which is B that is being achieved. So, now the temperature difference will be given by Tb minus Ta, which is delta T, change in temperature of the system. So the internal energy of the system can also be given by del U is equal to Ub minus Ua, where del U is the change in internal energy. Now let us consider the second case where the work is done through an electrical immersion heater. So when the work is done through an electrical way, the temperature from the initial system of Ta changes to Tb again. So delta T will be Tb minus Ta and delta U will be Ub minus Ua. So in both the cases, we can understand that internal energy is a state function which depends on the state variables. Now when work is done on the system, del U is positive, and when work is done by the system, del U becomes negative. So now let us consider a general case of heat. Consider a container in which a solution is present. We have a thermal conducting walls. So the initial state be A and the temperature be Ta of the system. And now let us consider the change in the internal energy is brought by keeping the solution in a reservoir where the temperature is more than the temperature of the system, where Tb is greater than Ta. So the change in the temperature Tb minus Ta will be denoted by Q, which is amount of heat absorbed by the system. In such a case, del U will be equal to Q, which is the internal energy. When heat is transferred from the surrounding to the system, Q becomes positive. And when the heat is transferred to the surrounding from the system, Q will be negative. Now, as a general case, let us learn what happens to the internal energy when work and heat is being transferred. So when a work is done or when the heat is being transferred, internal energy will be given as the sum of Q plus W, where it is heat plus the work done. Now assume a situation where there is no work done by the system or there is no heat transferred between the system and the surroundings. So in such cases, Q is equal to 0, W will be equal to 0, so del U will be equal to 0. So that shows that the sum of the internal energy of a system is constant, or I can say there is no change in the internal energy. Now, the energy of an isolated system is constant as there is no Q or no W being done between the system and the surroundings. In such cases, the first law of thermodynamics is being derived, which shows that energy can neither be created nor be destroyed. Now consider the pictures where you can see the water on the ground is at rest, but when the water flows from the top, it flows with the form of a kinetic energy which run the turbines and generate electricity. So the total energy of the system is conserved, which is the first law of thermodynamics, that energy of an isolated system is constant. So with this, I hope children you are able to understand today's class. So if you have any doubt, do let me know. Have a great day. Thank you. Take care. Bye.